All right, welcome to numbers 7 and 8 from the H8-8 worksheet. So let's see here. It says below are the complete graphs of some polynomial functions. Based on the shape and location of the graph, describe all the roots of the polynomial function. Be sure to include information such as whether the roots are double or triple, real or complex, etc. So looking at number 7 here, okay, we've got a function here, got a little curve. We can tell here that it is negative because it's going down to the right. We know that it's got an odd degree because the end behaviors are going opposite directions. So what we want to do here, figure out what is its degree so we can figure out what its roots are. Now we're only going to be able to figure out what the minimum degree is, remember, so let me get my colors out here so we can kind of draw on here and look at it. So if I was starting out here, let's say I started up here and I was working my way down. Remember, we need to identify all the mins and maxes here. Well, it looks like it's shifting directions right here, right? So it's going from decreasing to now increasing. And it goes up and increases up to here, and then it looks like it's going to switch again. So we had a min and now we've got a max, and now it's starting to head down the rest of the way down this direction. So remember, the number of mins and maxes we have there is going to be 2. And then if we add 1 to that, that's going to give us our minimum degree. And that would be 3 in this case. So our minimum degree is 3. So, and after we figure that out here, right, we need to figure out what our roots are going to look like. So let's identify our real roots first. If we look here, we're going to look for our x-intercepts. Here we have one x-intercept here, right? This is a single root, right? So we could say here we have one real, so I'm going to write it down below here. We have one real single root, which means then, when we take it here, our 3 is going to equal 1, our number of real roots, plus our number of complex roots. Well, to get 3 there, we know that we're going to have 2 complex roots. So those complex roots are somewhere up here, right? We don't see them on the graph, but we know that they exist. So we have 2 complex roots. So 2 complex roots plus 1 single root, it gives us a degree of 3. All right, let's look at the next one. Let's look at number 8 here. So with number 8, if I start on my graph here and I start going down, I'm decreasing down, I'm going to identify I have a min down here at the bottom. There's a minimum there. Now it's increasing as it goes up to here. And looks like it's going to shift directions and start going back down just barely, right? You'll see there, it kind of hits a bottom right there, and then there's a really, really small increase there. And then it's going to end up starting to go back down this direction. So the number of mins and maxes that we end up with here, right, we got number of mins and maxes is going to equal, we had what, 1, 2, 3, 4 of them? So our minimum degree here is going to be 5, right? So our minimum degree is 5. So if we're trying to identify our real and complex roots, again, we'll just go back and look for where it crosses the x-axis first. It looks like it only crosses the x-axis once. So, and it goes straight through. So we know this is a single root. So again, we'll write down here, we have one real single root. And then with our complex roots, right, we would have to have 4 of them because 4 plus 1 is going to give us 5. And we don't know if those are, going to be double, triple, all that kind of stuff here. They could be double, but we'll just go ahead here and say this is 4 complex roots. So there you go. That is the answers to number 7 and number 8 from H8-8. If you have questions about these, this came from section H8-6. Maybe you want to go back and check out that video and those homework videos if you have questions. Otherwise, shoot me a message there and I will do whatever I can to help you. Thanks for watching.